Kipsters will be able to find the area of irregular figures. So, there are several different ways to approach all of these problems. Some ways better than others, some ways more efficient than others. So looking at this first problem, at this point, most of you probably look at this problem and you think, I need to break this shape apart. So you start breaking it apart. Maybe you end up with 2 rectangles and a triangle. Maybe you end up with 4 rectangles and a triangle. Who knows? I agree with Triana when she says that's too much. So the way I'm going to think about that is I'm going to think about this as a negative space problem. I'm going to say, hey, what really happened here was I had a big rectangle and then somebody came and cut off the corner of it. It was probably Ariel. So, looking at this, I'm going to think about this as a negative space problem, where my area 1 was the original rectangle that I have, and my negative space, the area of my negative space, was this triangle that was cut off. So the area of my original rectangle, how much I originally had, RJ, is a rectangle, length times width. RJ, what is the length and width of the original rectangle that I had before Ariel came and cut off the corner? Okay, 5 centimeters. And what's the width? 9, because 9 goes all the way the length. We got to think about this. One thing that'll do a lot of you a lot of good is if you just really outline some of those figures as you're going through them. That will make you recognize, hey, that 6 doesn't go the entire length. It's the 9 that goes the entire length of my rectangle. So originally I had 45 centimeters squared, but
I cut off a piece.
Ariel came off and cut off a piece. Now this piece she cut off was triangular. It is this negative space here. I'm going to call it a sub n. One thing that just does is that reminds me when I'm done with it that it is a negative space. So it's to be subtracted, not to be added. So the base of my triangle in the 1/2 base times height goes from here to here. I don't know that value, but what I do know is that the entire rectangle is supposed to be 9. This part that goes from here to here is 6, which means that this missing piece that I have over here should be what, Marquita? The entire thing is 9, and this part is 6. That means this part is 3. Very good, Marquita.
Thank you to all Marquitas up in the room.
All right. Now, if I'm looking at the height of this triangle, Marquita, I know the height goes from here to here. And I know that this part of my original rectangle was 2, and the whole thing was supposed to be 5. So what is the height of this triangle?
5.
So our height here is 3. So we have 1/2 of 3 times 3 is 9. And half of 9 is 4.5. Now, Kip yes or Kip no? Do I need Kip yes or Kip no? I need to add these two areas. No, I don't need to add these areas. This is a negative space. So this was chopped off. This was cut off. So we had 45 until Ariel came along. And we subtract. That's going to give me 40.5 centimeters squared. So the area of that shape that was given to us was 40.5 centimeters squared. At least she didn't take the whole thing. That's true.
You'd be cutting off pieces everywhere.
All right. All right, so looking at this next shape, there are several different ways we could go about dealing with this shape. Most of you are going to look at this shape and you're going to see it as, hey, this is something I want to break apart into 3 rectangles or 3 rectangles or 3 rectangles or 3 rectangles, but there's another way we can look at this particular problem. Triana?
You can fill in the spot right there, that little square.
So Triana is saying, hey, let's think about this as if it had once upon a time been this large rectangle. So the part that we're looking for would be just this shaded area, and that means that this space here on the bottom is a negative space.
That's good.
Ariel is up to her old tricks again.
Why? Why?
I don't know why she's doing that.
Why can't Batman come?
The area of our original rectangle, what we had before.
What does that say? 8 what?
Before we got anything taken away, we had this large rectangle. What are the dimensions of my large rectangle? Solve. 16 by 8. All right, so we know that area of the original rectangle would have been 16 times 8, which is 128 square inches. But something was taken out. So we have to find the area of what was taken out. Now, in order to do this, I need to know the height or the length and width of this rectangle. So I need to know from here to here. So this entire rectangle, once upon a time, was 16. I can see that a piece of that is 4. I can see another piece of that is 4, which means that there's something left over here in the middle. Check your refrigerator. What are the leftovers?
Pizza.
Marquita, 8. So we know the length of our rectangle is 8. Now we need to know the width, which would be from here to here. What we can see is that this is actually, if we think about this as a line from here to here, this whole thing should be 8. Part of it is labeled as 2. So Cassandra, what is our missing piece here? 6. Had some people almost lose 10 paycheck dollars. That would have been really sad. So, Kip yes or Kip no? I need to subtract my 2 areas. Kip yes or Kip no? I need to subtract my 2 areas. Absolutely. We said this was a negative space, so it should be subtracted. 128 minus 48 is going to give me 80 square inches. All right, next one. Okay, over here, I have a shaded region, so this is going to be an obvious negative space problem. The original space that we had was this rectangle. So our original space, I'm going to call it A sub 1, is equal to length times width. And what are the length and width of our original space? Monia. 7 and 6. 7 times 6 is 42 square inches is what we originally had. Then somebody came out with this circular cookie cutter and took out a piece of it. It was me. I just got hungry.
Come on.
So we'll call this a sub n. This is our negative space. This is our space that was taken out. Now, our negative space, the shape of our negative space is a circle. So we're going to have to be finding the area of a circle. Somebody with a raised hand, please remind me, what is the area of a circle? How do we find the area of a circle? What's the equation for area of a circle? Jefferson? Pi times r squared. Good news is they've got the radius labeled for us. That's super easy. So we have pi times our radius, which is 2 squared. And we'll do pi times 4.
What?
And today I'm going to let things be super simple. I know that you know pi is equal to 3.14. Today we're going to say pi is approximately 3. We're going to round even closer.
Thank you.
3 times 4 is 12. Kip, yes or Kip, no. I am going to add these two areas. Kip, yes or Kip, no. I'm going to add these two areas. No, I am not. This is a negative space problem, so that means that we are subtracting. Originally, I had 42. I'm subtracting out 12. And we are going to get approximately 30 square inches. Now, keep in mind, this is an approximation because we definitely rounded pi pretty significantly. So it's about 30 square inches. All right, questions? Deidre. You will do whatever the homework tells you to do. Other questions about previous problem? Triana.
Must be about this one?
About the previous problem, the one that we're working on, or the one we just finished.
I have one before that.
We'll come back to that then. All right. Next problem. Marquita, question about the previous problem.
If we would have did 3.14, what would have been our
We would have gotten 12.56. When we would have subtracted 12.56, we would have gotten 29.44. Itzy. Oh, yeah, look at my units there. Come on, Mr. Boots. Get your whack together.
If there's
Step your game up. All right, last one.
Units, it's centimeters, right?
Now, looking at this particular problem. Now, I can see that this particular problem looks like it's kind of messed up. What are we going to do here? I'm confused. What should I do here? I don't know. Tufa, thank you for raising your hand without making extra noises. Tufa, thank you for raising your hand without making noises. What are we going to do here?
She doesn't know.
Ariel, what are we going to do?
So, like, at the top is like a circle shape, and you can make the other half of the circle.
So she's asking to make the other half of the circle. Now, I'm going to push back on that, and I'm going to say, okay, if I find the area of this circle, I get this left over.
You can't make a triangle.
So this doesn't quite work for us because we're going to end up with this other awkward shape that we can't find the area of. Let's find a different way.
No, that's not even a shape.
Cassandra, what do you think? Can we make a half circle? Absolutely, let's make a half circle. So we know that the area of this half circle would be half of the area of the full circle. So what we're going to do is we're going to treat this area 1 and area 2. So area 1 is half of a circle. So we're going to take the area of that circle, which would be pi times r squared, and then we're going to multiply by 1/2. So this is a formula for the area of the half circle. All we did was take the area. Hey, this circle could have been whole, would have been pi r squared, but we only want half of it. 1/2 times pi times r squared. So looking here, we have 1/2 times pi times 3 squared is 9. I said we were going to substitute in 3 for pi today, so 1/2 times 3 times 9. 1/2 of 27. And that would be 13.5.
That's a
Was there a simpler way of doing that?
No. All right, so the area of our second shape is a rectangle. I see it's clear that my length here is 20, but I'm having trouble determining what the width of my rectangle is. Can somebody help me out? Somebody with a raised hand, somebody help me out. What is the width of my rectangle? What is the width of my rectangle? Mr. LaRue.
3.
It is not 3 because 3 only goes from here to here. Where did 9 come from? So we don't want to multiply 3 by itself. We actually want to find the diameter of this circle, and the way we find the diameter of this circle would be to Jefferson. Yeah, multiply by 2, because it's like this is 3 inches and 3 inches, which would give me 6 inches. So we're 20 by 6 over here. Would give me 120 square inches. Now, I found 2 areas here. Kip yes or kip no. I want to add these 2 areas. Kip yes or kip no. I want to add these 2 areas. Thanks for everybody who's showing me kip yes. Boo to the rest of you who are not showing me anything. So we have 120 plus 13.5 would be 133.5 square inches. All right, is there anybody who would like to share a key point for today's lesson? Jaime. All right, so to solve problems using negative space, negative space, find the original area. Oop, that's misspelled. Original area. And subtract the negative areas, the negative space. Anybody have a second key point? Anybody? Anybody? Nope. Nope. Nobody? Oh, Triana.
Oh, you must have
Okay, so my point is that when you see the little shapes, right? The shapes. Okay, so instead of putting them into like smaller shapes, like the first one or the second one, instead of putting them into small shapes, you can make them into the negative.
So this is kind of, this is an interesting key point. Not one that I'm going to put down, but I think is definitely a big picture idea that you need to be taking away, is that some problems are easier done breaking into smaller shapes, but some problems may be done easier by making a larger shape and using negative space. I think that's kind of a big idea. Not necessarily one of the key points, though, of this lesson. Christopher, did you have a key point of this lesson?
Yes.
What'd you have?
Cause like you see how there's a the 2 centimeters in that part. Oh, wait, did she just say this? Like how it ends where like there's like a bold spot or like where the line ends and stuff. Never mind, it's not smart.
Bonilla, what did you think?
You know how like it has a shape inside of another shape?
Yep.
You have to subtract, but this other one, when it's just this one, when it's just they don't have another shape inside of it, or something, I don't know how to say it, but you add it.
All right, so she's saying if you solve by breaking down a shape, if you solve by breaking down a shape, you add the areas of the pieces. Okay.